This is Mr. Martin. These are the video notes for section 9.6. In this video, I'm going to be talking about families of right triangles. So, in certain cases, if we have three numbers, three whole numbers, that's really important. Make sure you make a note of that, highlight this or something. If we have three whole numbers that satisfy the Pythagorean theorem, here's our Pythagorean theorem, we call those three numbers a Pythagorean triple. Okay? We can have an infinite number of numbers that satisfy the Pythagorean theorem, but if those three numbers happen to be whole numbers, then we would say that they're a Pythagorean triple. So some of the common Pythagorean triples that you may want to memorize, they'll make your life a lot easier. Instead of having to show the Pythagorean theorem, you could just write that it's a triple. We've got 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. And there's, again, an infinite number of possibilities of Pythagorean triples. There's actually some formulas that you can use to generate them. But if you can memorize at least these five, again, it'll make solving problems a lot easier in certain cases. So we'll often talk about members of a family. Okay, if we have a triangle that has sides 6, 8, and 10, it's going to be a right triangle because it satisfies the Pythagorean theorem. If I divide all these sides by 2, I would get 3, 4, 5, which is one of our Pythagorean triples. So we would say that 6, 8, 10 is a member of the 3, 4, 5 family. We wouldn't count it as a Pythagorean triple, but we would say that it is a member of the 3, 4, 5 family. And then, kind of along the same lines, we've got a triangle with sides 1.5, 2, and 2.5. This is our 3, 4, 5 divided by 2. Again, this would form a right triangle because it satisfies the Pythagorean theorem, but it would not be considered a Pythagorean triple. If you think you know why, go ahead and write that in there and then let me know in class. Alright, so the principle of the reduced triangle, oftentimes it's convenient to reduce a triangle to one that it is similar to. By doing so, the problem can become a simpler one. Although this is never necessary, it can often save time. For example, if I want to solve for x here, I've got that this side is 20, and this side's 35, and this side is x. So if I divide each side by 5, I would get a new triangle that's similar. This is a right triangle, by the way. So this side would be 4, and this side would be 7, and this side would be x divided by 5. So normally at this point, I'm going to assign this expression a different variable and just let it be y. And then I'm going to solve this triangle for y, then solve for x. Okay, so we could do Pythagorean theorem on the original triangle. We're going to have really large numbers. We're going to have to do some simplifying at the end. Or I could solve this simpler one where I would have 4 squared plus 7 squared is equal to y squared. So this is 16 plus 49 is equal to y squared. Y squared is equal to 65, so y is equal to the square root of 65. Again, I want to remind you that according to algebra, we would need a positive and a negative answer when we take the square root of both sides. But since we're talking about a figure, really we only need the positive number. So we did the solve for y part. Now we need to do the solve for x part. So we're going to plug y into this expression. So I've got x over 5 is equal to root 65, and then just solve this for x, and I get x is equal to 5 root 65. We can put this over 1, and then we just cross multiply. And there you have your answer. So again, Really not necessary. If you use 20 and 35, you're going to end up with some very, very large numbers, and it's just easier to reduce a triangle first and then go back and solve for x at the end. All right, let's take a look at another example. In this case, we have a decimal side, so instead of dividing everything by some number, we may want to multiply. So I'm going to multiply by 2 to get a new triangle, obviously not to scale. So this is going to be 8, this is going to be 15, this is going to be 2x, and again I'm going to let that be y. And here's a spot where if you memorize your triples, you can see, oh, I have two legs, 8 and 15. I know my third side has to be 17 because it's a Pythagorean triple. So if you're going to use Pythagorean triples on quizzes or tests, this is how I want you to show your work. You would say y is equal to 17, and then in parentheses you would put 8, 15, 17, triple. Okay, this is considered your work. If you don't show this, you're not going to get full credit. Alright, so we solved for y. Now we can go back and substitute that in to our expression over here. So 2x is equal to 17, which means that x is equal to 17 halves. Okay? Again, if you are working on your homework and you have questions on how to show the work, make sure that you ask me. Alright, let's look at a couple more examples and then we'll be done. We want to solve for x. So again, these are all right triangles. I've got two sides that are 5 and 12. If you remember your Pythagorean triples, then this is simply a matter of saying that x is equal to 13, and then your work would be 5, 12, 13, triple. Alright, last example, we've got two sides of 3 and 4. Now this is a case where you have to be really careful, because if this was a Pythagorean triple, then the x would be 5. It would be a 3, 4, 5 triple. But can you see the problem with that? What's the problem with having this leg be 4? Well, the problem is that in a right triangle, the hypotenuse should be the longest side. So really, if this was a 3, 4, 5 triple, this 4 would be over here. So this is a case where you have to be careful, and we're just going to have to use Pythagorean theorem. We're going to have 3 squared plus x squared is equal to 4 squared. So 9 plus x squared is equal to 16. X squared is equal to 7, and x is square root of 7. Again, when you take the square root of both sides, algebraically you do need a positive and negative, but in this case we just need the positive because we're dealing with a figure. Alright, so that's it for section 6. If you had any questions, just jot those down and ask me the next time you see me in class. Let's scroll back up here. Did you fill in an answer to why this would not be a Pythagorean triple? It's because they are not whole numbers. Okay, in order for it to be a Pythagorean triple, they've got to be whole numbers. Alright, that's it for this video. We'll see you next time.